All right, just had one more video here, one more video lecture about chapter 34, and that is optical instruments. And so I'm not going to say just a whole lot here, uh, uh, perhaps, uh, but optical instruments, I mean, there's all kind of optical instruments. You got cameras, you get microscopes, telescopes, and so forth. I'm just going to work on two things right here for you. I'm going to talk about the magnifying glass and telescopes. So the magnifying glass, basically you have an object here that you're looking at, and here's your eye looking at it. And the problem is that it's only a certain size, and you want it to be bigger than that. And so what you do is you put a lens between you and the object. So you put a lens in here. Now, if the object is closer to you than the focal length of the lens, then what happens is you get a virtual image, and the virtual image is going to be bigger. Okay. And so the idea would be that the image now looks larger than the original thing, particularly if the closer the object is to the focal point, the bigger the image is going to be. And so what you want is you want the image to look as closest to you as possible. You want the image to look like it's at 25 centimeters. And so the magnification of your magnifying glass is going to be the angular size of the image divided by the angular size of the object. Well, angular size of the object, so angular size of the object is going to be approximately the size of the object, so the height of the object, okay, divided by the distance to the object. So the distance, to the object. Okay. Angular size of the image is going to be height of the image over the there. So what we're going to do is we're going to assume the image is a distance of 25 centimeters from you. Okay. And so if you do that, and if you assume the object is real close to the focal point right there, then what you find is that the magnification, again, magnification is also height of the object over height of the image over height of the object. Okay. And so what we find is, plugging all this in, the magnification is approximately 25 centimeters divided by the focal length. Okay. So for example, you've got a lens, and you discovered that the lens has a focal length of 14.5 centimeters, and so you want to know, what's the effective magnification, and this is going to be the maximum magnification, because if you move the lens around, you're going to have bigger or smaller magnification. So the maximum magnification is just 25 centimeters over 14.5 centimeters. Okay. And so what you come up with is a magnification of about 1.7 times, or so 1.72 or 1.7 times. So there's your magnification. So that's like an almost magnification of 2. And so that's how your simple magnifier works. The other thing here that we run into is a telescope. And the simplest telescope basically just has 2 lenses. So you have an object that's really far away. Okay, now for an astronomical telescope, the object is, close to infinity. So that's going to be very far compared to the other dimensions that are here. And so the light comes in here. And so as the light comes in here, it's bent down to focus. You get an image. If that image is closer to the other lens, then that image becomes, if it's closer to the focal length of the other lens, that image then is magnified. So in other words, you end up with a virtual image that's out here somewhere. And so what happens is that for your eye looking through here, the original thing looks like that, the image looks like, so you get magnification. Again, it's a little. I'm not gonna belabor the point. You can look through some of the work in the book here. But magnification of an astronomical telescope, we call this the objective lens. This is the eyepiece, because that's the part that you look through. Okay, so the objective lens has a certain focal length. We're going to call it f sub o. This is going to be f sub e. The magnification is f sub o over f sub e. So there's your magnification for an astronomical telescope, a simple telescope. Some of the telescopes that we use in the class have a focal length of, for the astronomy class, we have a telescope that has a focal length of 2,000 millimeters. And so we have a whole bunch of different eyepieces. And so you change out the eyepiece to get different magnification. So if you have an eyepiece that's 40 millimeters, then your magnification, remember magnification is focal length of the objective divided by focal length of the eyepiece. So the magnification in that case is 50 power. If your eyepiece is 20 millimeters, then the magnification is 100 power. If your eyepiece is 10 millimeters, then your magnification is 200 power. And so that's all there is to it for astronomical telescopes. So that's kind of a useful thing to know, that it's that simple here. And so if you have a magnification you're trying to achieve, then if you know the focal length of the objective, then you can find it by figuring out which eyepiece you need. Likewise, if you know the focal length of the objective and you put an eyepiece in, you can then just divide and find the magnification of the telescope. And so that's not a bad thing to know right there, since it's so simple. And knowing that I'm an astronomer, it's kind of like generally a good bet that there's the possibility of a telescope question on the test. And so we're past the third test, so there'll be a telescope question on the final. And so it's that simple to do it. So there we have it. Optical instruments. Sweet and simple. We're not going into as much detail here as we might, because none of y'all indicated you were going into optics or so. But this is it. So that covers the last little bit of that chapter that we need to cover.